All right, so this last unit that we're going to work on for college algebra is going to be about exponential and logarithmic functions. All right, now what's really nice about this is that every single one of you have spent plenty of time talking about exponential and logarithmic functions. All right, so I'm confident that we're going to do awesome on this last test. All right, so the objectives for today, we're going to look at evaluating exponential functions. All right, mostly word problems today, as well as finding equations with the information given. And then the last part of class, the second part of class, is going to be about using compound interest. All right, and any of you that are interested in doing business when you go to college, you will take at least, unless you end up being a finance major, you'll at least take an introduction to finance course where you will use this idea of compound interest. All right, lots of problems done with this. Okay, so if anyone's planning on business, this is something you'll see pretty soon, a couple of years. Exciting. All right, so let's take a look at this problem. Read this for us, Jalen.
The population of India was about 1.25 billion in the year 2013, with an annual growth rate of about 1.2%. This situation is represented by the growth function P of t equals 1.25 times 1.02. Is that t?
That's a T, yeah.
Where t is the number of years since 2013. What would the population of India be in 2013?
All right, so they've given us a formula. Oh, I just wanted to flip the numbers. Sometimes I like to do that with my brain. No, 2013, 2031. No, you guys don't do that? No?
Yeah, you know.
No, it wasn't an accident. I mean, I can't do since 2013. It'd be, I don't know the answer. Because I was making up a year, and I thought, what better?
Oh, not like,
You knew
What? I knew that it wouldn't. I didn't think it would be this much chaos. Now, Jalen, I really like the way that Jalen read the function. You guys hear how he said P of t? That was well done. P of t. We had a little trouble with the t. The power of t is probably hard to read on your paper. I'm sorry. And it's hard to read up there. But that t, after the 1.012, is in the exponent. So whenever you have a variable in the exponent, this is called an exponential function. All right, so we're going to write down 1.25 times 1.012 to the t power, or the power of t. Does anybody know how they got 1.012 in those parentheses? How did they get 1.012 in parentheses? What did they do? They made the growth rate a decimal. So what is 1.2% as a decimal? Very good. So how did they get 1.012? Because it's always going to be 1 plus your growth rate if this is exponential growth. What will it be if it's 1 minus this rate? Do you know what that's called? It's called decay. Very good. So it's exponential decay where the population is declining. Then we would use subtraction. Any questions on how they got 1.012? I know it's given to us, but I want you to show you've actually done this before. All right, so now we need to plug in a number for t. How many years has it been since 2013 when we're looking at the year 2031? 22? 22 years? 18 years. So that means I'm going to substitute 18 for t. So 1.25 times 1.012 raised to the 18th power. You should take out your yellow calculator right now. If there's not one on your desk, look on the floor. They're everywhere. Or look next to you, Peter. And let's see what we expect the population of India to be in 2031. You should be typing in everything after the equal sign.
549.
So 1.55 billion people? All right, if we round it. Any questions on evaluating an exponential function? Everybody good with that? I would say that's more the straightforward question. We're going to go to the second example. This one gets a little trickier. All right, we're going to make it a little more challenging. All right, read this one for us. Emmanuel. This is example 2 about deer.
In 2006, 80 deer were introduced into the wildlife refuge. By 2012, the population had grown to 180 deer. The population was growing exponentially. Write the algebraic function n t representing the function n of deer over time t.
Excellent. All right, so I know that in my function, in my answer, I am going to have n of t, where n is the population deer over time t in years. All right? Now, if you think back to the problem we just did, bless you, if you think back to the problem we just did, the first number we're going to write is the first population number given in the problem. All right? Which is in 2006. So I'm going to write here 80 deer. All right? Times. Do I know the growth rate? Just tells me it goes from 80 to 180 from 2006 to 2012, and it's growing exponentially, but it doesn't give me the growth rate. So I'm going to write 1 plus r. Bless you. 1 plus r. All raised to a power of t. Now, there's too many unknowns here. If you guys look at what we just wrote, we have too many unknown variables. We don't know r, and we don't know t. Is there a way we could use other information for the problem to get our unknowns down to 1? Because if we have one unknown variable, we can solve for it. So what information have I not used yet?
180.
The 180. Now, where is 180 going to go? Very good. The 180 is going to go at n of t. And how many years since 2006 is 2012? 6. So at t, I'm going to put 6. So I'm going to put 180 where it says n of t. I'm not changing 80. I'm not touching 1 plus r. But my power of t is going to be 6 years. Because 6 years since 2006, we have 180 deer. All right, so 6 years from 2006, we have 180 deer. Everybody good on there?
Is that why we didn't put the parentheses 6 on the side of 180?
You could write n of 6, but n of 6 is 180.
Oh.
They're the same thing. Right? The population of deer 6 years from 2006 is 180. They told us. You good with that? Okay. All right, so now we're going to solve for r. What do you think is the first algebraic step I'm going to do to solve for r? Divide by 80. So we're going to do that in your calculator. What's 180 divided by 80? 2.25? Excellent. Okay, how am I going to get rid of this power of 6? Yeah, I know, right? The 6th root. Have you guys ever done a 6th root before? Man, what a day. What a time to be alive. Let's do a 6th root. So I'm going to draw a big radical symbol. How do I know that it's a 6th root? Do you know what that's called? Yeah, I know that little area. Do you know what that's called? Anyone? Ooh, this would be, you would really score a lot of bonus points with your teacher if you knew what that was called. We're going to put a 6 right here. Do you know what that's called? Not the bracket. What is it? Hexaroot. Well, no, okay. You're trying to tell me what type of root it is. Fair enough. I'm just asking, what is that number called when you put it right there? Man. If only you were listening 2 years ago. That's a great question. And we don't know the answer. But luckily I do. It's called the index. No? No one remember that? We knew it, but we didn't. Okay, so do the same thing over here. So in your calculator now, you should do the 6th root of 2.25. Does anybody need help on those buttons? They did 180 over 80. If you hit, do you guys see the one that has the square root symbol with like the little X on the index? If you hit second, that one? Nope, that's not what I want.
Type 6 and then.
You're right, thank you. It's been a long time. Type 6 first, then second that one, which is like the caret. Oh, this one needs to be reset anyway. There we go. Okay, so 6, second that one. There we go. And what did you get, Yasmin? 1.145? 1.145. How did I write 6 there? I'm sorry. That's supposed to be an R. My bad. All right, so what is the growth rate? What is the growth rate for this scenario of deer? Very good, 0.145. Or, I think I heard Susanna saying it, 14.5%. That's a pretty good growth rate for these deer. Now, is that what the question is asking me to do? No, it's asking me to write the function. So I'm going to write this function. Let's write it over here. I'll use a different color so you know that this is going to be the answer. The answer is n of t equals, how many deer are we starting with? 80 times 1.145 raised to what power? The t power. You'll notice it's not 6, because now we're saying you can plug in any number for t. So what if they change the problem to say, okay, in 2012 there's 180 deer. What about in 2022? Now you could plug in 16, and you would have your estimate for how many deer would be there. All right? Questions on this process? A little more stuff to do here than the last one. Yes?
Wait, so for the final, are we going to have stats or are we going to have college algebra?
Stats. Questions about this? All right, we've reached the end of this micro lecture. Stand up